So the last topic of S block chapter is that of calcium sulfate, which is in your syllabus, and the other compounds of calcium and S block elements are not in the syllabus. However, calcium sulfate is in the syllabus. So it is a calcium sulfate hemihydrate, means the plaster of Paris. What the plaster of Paris essentially means, basically that, for example, this is calcium sulfate hemihydrate. This does not mean that there is only half molecule of water. See, half molecule of half atom or half molecule concept does not exist. This is not possible. So this essentially means for every two calcium sulfate molecules, calcium sulfate ions, there is one water molecule attached. So for every two there is one, so for every one effectively we write it as half. So this means calcium sulfate hemihydrate, right? So it is how is it actually prepared? This is prepared in the following manner, that what we do actually we heat the gypsum at 393 Kelvin. Basically we boil the gypsum at 120 degrees centigrade. Gypsum is what basically, this gypsum means calcium sulfate dot 2H2O. We heat this at 120 degrees centigrade approximately. We boil it, and what it does do is that it breaks it down into calcium sulfate hemihydrate, half H2O plus 3 by 2 H2O is released, which is not the proper number. So we multiply each and every thing by 2. So we multiply this by 2. So the final that we get is 2 calcium sulfate dot 2H2O when heated at 120 degrees centigrade. This gives us 2 calcium sulfate dot H2O, 1 H2O, right? So if this entire thing is multiplied by 2, this means calcium sulfate is multiplied by 2 calcium sulfate, and this half is also multiplied by 2. This means 1 H2O. So dot H2O plus 2 into 3 by 2 means 3 H2O is being released, right? So this is how we write the equation. Above 393 Kelvin, no water of crystallization is left and anhydrous calcium sulfate is formed. So what does it do? That if we heat this if we heat this calcium sulfate, if we heat this gypsum CaSO4.2H2O, this is gypsum basically. So if heat it beyond, if we basically heat it beyond 120 degrees centigrade, more than 120 degrees centigrade, so what does it do? It releases all the water of crystallization is released basically. Okay, all right. So the entire water of crystallization is happens. The gypsum, when burnt in more than 120 degrees centigrade, loses all the water of crystallization, and the plaster of Paris will not be formed, right? So calcium sulfate is formed, and this basically this class calcium sulfate without any water of crystallization is known as dead burnt plaster. This is basically known as dead burnt plaster. This is known as dead burnt plaster. Basically this is known as dead burnt plaster. Okay, so it has a remarkable property of setting with water, and on mixing with an adequate quantity of water, it forms a plastic mass that gets into a hard solid within. So the property of plaster of Paris is that when the water is added to it, it forms a hard mass, right? It forms a hard mass. So this is the property basically. Okay, and the usage, since it forms a hard mass, so it can be used as a protective cover for something, like for example, if your leg or hand gets fractured, if any body part gets fractured, then we cover it with plaster of Paris, right? And it is also used to make some kind of masks and something, which is also used. And the largest use of plaster of Paris is in the building industry as well as the plasters. It is used for immobilizing the affected part of the organ where there is a bone fracture or a sprain. right? So what does it do? It is a hard mass basically, so it immobilizes that part. When the plaster of Paris is basically applied to that fractured part of your body, it immobilizes it. It is that fractured part will not be able to move. So so if it is not able to move, so since no movement, so no pain. So this is how it goes on. So that immobilized part self heals after some days, then we remove the plaster of Paris, okay, from the body. It is also used in dentistry, in ornamental work for making the casts of statues and busts. So cement. Now, what is cement basically? What is cement? Don't get confused. This gypsum is not cement. Okay. So somebody would tell this CaSO4.2H2O. This is cement. No, that's not right. If this is the question, so that's not right. That is false. Cement is a complex mixture of. It is basically not even a compound, it is a mixture, okay. So it is a complex mixture of many different compounds, not only this, not only calcium sulfate. So we'll discuss what cement precisely is. Cement is an important building material. It was first introduced in England in 1824 by Joseph Aspdin. It is also known as the Portland cement because it was invented in Portland, in the Isle of Portland. Okay, so it resembles basically with the natural limestone quarried in the Isle of Portland. So that's why it is known as Portland cement. Cement is a product obtained by combining a metal rich in lime, in calcium oxide, with other metals such as clay, which contains. So what are the contents of this cement? Cement means, cement essentially means calcium oxide, which is lime, right? And then it is reacted with clay, which consists of silicon dioxide along with oxides of aluminium, iron, and magnesium. So this is essentially clay, okay. So the composition of Portland cement is basically calcium oxide is calcium oxide is around 50% of cement, total mass of the cement. 50 to 60%, right? We can call it basically 50 to 60%, right? And SiO2, which is silica, this is basically 20 to 25%, right? And Al2O3 is basically, it is just 5 to 10%, right? Okay. And this MgO2 is 2 to 3%, basically MgO is 2 to 3%, and Fe2O3 or Fe3O4, whatever it is, ferric oxide is just 1 to 2%, and SO3 is also there. So the oxide of for example sulfur is also there, so this sulfur trioxide is also there. This is also like 1 to 2%. So this is overall content of cement, what we can see in cement. Calcium oxide is the maximum amount, and after that 20 to 25% is silica, okay, which is majorly of clay. And other components of clay include aluminium oxide, iron oxide, magnesium oxide, and sulfur trioxide. So these are in 5 to 10%, 1 to 2%, 2 to 3%, and 1 to 2% respectively. So this is the basic composition of cement basically. So for a good quality cement, the ratio of silica to alumina should be between 2.5 to 4, and the ratio of calcium oxide to the total oxides of silicon, aluminium, and iron should be as close as possible to 2. So for a good cement, what what is it telling basically? For a good cement, the ratio of silica, the percentage of silica to alumina should be between 2.5 to 4. So as we know that silica is nearly 20 to 25%, and this is nearly 5 to 10%. So hence the ratio is nearly equal to 2.5 times to 4 times. So this is correct. This is correct. If you just see the range of this 5 to 10%, and this range is 20 to 25%, so the ratio will come out to be nearly equal to 2.5 to 4 times, which is correct. All right. And the ratio of the silica to the rest of total of alumina, okay, and and the ratio of this calcium dioxide, CaO, to the rest of the clay, this should be nearly equal to 2 times. So this is correct also. For example, calcium oxide is nearly 50 to 60%, and the rest of the clay and silica is nearly equal to 40% only. So the ratio is nearly equal to 2 or more than 1.5 times. right? So this is also correct. All right. The raw materials for the manufacture of the cement are limestone and clay. When the clay and limestone are strongly heated together, they fuse and react to form cement clinker. Okay. So what are the raw materials for this cement? And this is basically clay and limestone. Limestone is nothing but this calcium oxide, slaked lime. And what is this? Clay is limestone means precisely limestone is actually calcium carbonate, which consists inside which calcium oxide is there. When this calcium carbonate breaks down into calcium oxide when heated, and clay consists of silica SiO2, and after that the oxides of aluminium, iron, etc. Okay, as we have seen. So what they do when they are strongly heated together, when this clay and limestone are strongly heated together, when they are kept together and heated together, they form cement clinker. The cement clinker is mixed with 2 to 3% by the weight of gypsum to form cement. So what it does, when they are heated together, they form cement clinker. And this cement clinker, when added with gypsum, okay, when added with gypsum, and only 2 to 3% by the weight, and 98 to 90%, 97% will be cement clinker, this will finally form the cement. The cement clinker will form the cement when it reacts with the gypsum. Basically this is nothing but gypsum. Calcium sulfate dihydrate is gypsum. Okay, we know this, right? So the important ingredients present in Portland cement are, see this. So as we know, this cement clinker will consist of silica. It will consist of silica, yes or no? It will consist of calcium oxide, yes or no? It consists. And this consists of calcium sulfate, right? So when this silica and calcium oxide and calcium sulfate react, this will form calcium silicate, Ca2SiO4. Why? How? The silica from this clay will react with this gypsum, calcium sulfate, to basically form this CaSiO4. Okay, all right. And similarly, other compounds may get also formed. For example, this this dicalcium silicate and tricalcium silicate can also be formed. Ca3SiO5. This is 51%, and tricalcium aluminate is also formed, which is 11%. So, what are the contents of Portland cement? Alright, what are the important ingredients of Portland cement, which we can call basically? See, the following ingredients are there in Portland cement. The following direct ingredients are there after the reaction of this entire thing with gypsum. Cement is formed. And what are the contents of cement basically? One is Ca2SiO4, calcium disilicate, which is like 26% of the cement. Then calcium trisilicate, Ca3SiO5, which is like 51% of the cement. All right. And the other is calcium tricalcium aluminate, Ca3Al2O6, which is like 11% of the cement. So these are the major ingredients of the cement after this lime reacts with the clay, which consists of silicon dioxide, SiO2, which is silica, aluminium oxide, iron oxide, magnesium oxide, sulfur trioxide. Okay, and these things basically, when this limestone reacts with clay and these are heated together, then what they form? They form cement clinker. And cement clinker, when it forms reacts with this gypsum, which is calcium sulfate dot 2H2O, this gypsum, then only cement is formed. And the constituents of cement, major constituents are this: dicalcium silicate, okay, dicalcium silicate, tricalcium silicate, and tricalcium aluminate. Why tricalcium? Because Ca3 is there. And this is dicalcium silicate. Now, so the last topic is the setting of cement basically. So when mixed with the water, the setting of cement takes place to give a hard mass. Okay, as we know, the cement's property is such that when it reacts with water, okay, it gives a hard mass, like plaster of Paris does. So cement, when it reacts with water, it gives a hard mass. So this is the property that is useful in cement and makes it one of the most valuable compounds in the for human beings basically. Okay, this is due to the hydration of the molecules of the constituents and their rearrangement. So The purpose of adding the gypsum is only to slow down the process of hardening of cement so that it gets sufficiently hardened. So the purpose of gypsum is, why gypsum is added to cement? Why gypsum is added to cement? Cement essentially means cement clinker, which consists of clay plus calcium oxide. Okay, so this is done to reduce the speed of hardening, to decrease the speed of hardening such that efficiency of hardening is very good. The more time it takes to harden, the better it gets hardened. Okay, so the efficiency of hardening increases, right? This is why it is done. So the uses is, cement has become a commodity of national necessity for any country from next to iron and steel. So iron and steel are one of the most important components which are used in bridges and buildings and etc etc. Similarly, cement is also an equal indispensable and valuable product. It is used in the concrete and reinforced concrete and plastering in the construction of bridges, dams and buildings, as we know that. Okay, so that's this topic winds up our S block, and the next topic what we'll be covering is P block.